right, so this is section 1-6, absolute value equations and inequalities. Our learning objective is to write and solve equations and inequalities involving absolute value. Do not write this down, just this is for information purposes only. An absolute value quantity is non-negative. Since opposites have the same absolute value, an absolute value equation can have two solutions. Does it mean it always has two solutions? No, but it can. And we have to take that into consideration. Okay, I do want you to write this on your paper. Absolute value is its distance from 0 on the number line. How far away from 0 are you? That's the true definition of absolute value. When you guys take standardized tests, they will try to work that in somehow, that you know the fact that absolute value is how far away from 0 on the number line you are. I put these down here. You don't have to write them down if you already know them. But it looks a little something like this. Absolute value of 4 is 4. Absolute value of -4 is 4. Absolute value of x is x if x is greater than 0. Absolute value of x is -x if x is less than 0. So if you're inputting a negative number into the absolute value, you're going to get out the opposite of that negative number. The opposite of -2 is 2. So if I put -2 into the absolute value, I'm going to get out 2, which is the opposite. If you put in, this is where I can tell how big your math muscles are. I have some people who forget and just go on blind intuition, and they will put in a positive number and get out a negative number from the absolute value, but we know absolute value represents distance, and nowhere in our universe is distance negative. In no way can I move a negative distance. My distance that I move is always going to be positive. No way. It's like, right now there's no time travel. No way you can move back in time. Same kind of concept. All right. We are going to do 2 example problems, so I want you to write these both. If I'm writing this on my paper, I just write absolute value 2x minus 1 equals 5, and I don't write the other instructions because what we do is going to determine that we're solving it and we are graphing it. Okay, so I'm going to scoot this one over. That's the second one. All right, so the first step in absolute value is to rewrite as 2 equations. There are possibly 2 solutions, so we're going to take into account both. So what you do is you write it just as it looks. And then you write it with the left hand, the non-absolute value side, negative.
Couldn't you just do plus or minus?
I am not able to solve it with a plus and minus because sometimes it gets a little crazy over on the right-hand side. So I just write 2 separates.
Okay.
And it keeps my brain a little bit clear. So for each of these equations, I'm going to add 1 to both sides. And divide by 2. So my 2 solutions are x equals 6 divided by 2 is 3, and x equals -2. We want to make sure that both of these work, so when I plug in 3, I should get out 5. So 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. So this checks out for sure. The next one is negative 2. That's 5. So 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. Absolute value of negative 5 is 5. So both of these check out. So now I'm going to invest the time in actually graphing both of them. I have a number line graphing sheet. I just put the numbers that I want on the number line. So what is the solution? X is equal to 3. And X is equal to negative 2. That's the solution. All right, so on your paper, put absolute value of 3x plus 2 equals 4. We are again going to graph the solution. So I'm going to write the two equations. (3x plus 2 equals 4) and 3x plus 2 equals negative 4. If there were anything on the outside of my absolute value, I would add, subtract, multiply, or divide to get it onto the other side. Okay, so now that we have our two equations, we're going to solve both of them. So for both of them, I'm going to minus 2 from both sides. And for both of them, I'm going to divide by 3 on both sides. So my two possible answers are 2/3 and negative 2. I have to check both of those because I'm not going to invest the time in graphing if one of them is not a real solution. So 3 times 2/3 plus 2 should equal 4. 3 times 2/3, well, 3 over 1 times 2/3, so 3 cancel, and I have 2. 2 plus 2 is 4, which matches, so this 2/3 check out. And then we'll try it with the negative 2. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. Absolute value of negative 4 is 4, so that also checks out. So when we graph that on our number line, our solutions are negative 2 and 2/3. All right, so here's a scenario where I have other shenanigans going on with my absolute value. So the first thing I do before I do a positive and a negative, I'm going to add, subtract, multiply, and divide to get just the absolute value and what's inside on the left-hand side and everything else on the right. So make sure on your paper you write 2 absolute value of x plus 9 plus 3 equals 7. So the first thing I'm going to do, it would be as if I'm looking at this absolute value like I would if it were, the whole thing were just x. So I'm eliminating everything except the absolute value. So I'm going to minus this 3 from both sides and get 2 absolute value of x plus 9 equals 4. Then I'm going to divide by 2. Absolute value of x plus 9 is equal to 2. Now I'm in a position where I was up here, where I'm going to do the positive version and the negative version. So So I'm going to write this as x plus 9 equals 2, and x plus 9 equals negative 2. Somewhere you guys are going to have to memorize, when I'm dealing with absolute value equations, I should have both a positive and a negative version. This process should be in your memory bank. Somehow memorize this. So in both situations, I'm going to subtract 9 from both sides. So my answers are x equals negative 7 and x equals negative 11. We are going to test that. It's pretty easy to test. I trust my math up here on this part. So negative 7 plus 9 is 2. Absolute value of 2 is 2. Negative 11 plus 9 is negative 2. Absolute value of negative 2 is 2. So I have checked both of these. They are solutions. Make sure when you graph these on your number line that the negative 11 is on the left-hand side, the negative 7 is on the right. And they both get a closed circle on the number line. I guess if we want to make it a true number line, then it would need arrows. Otherwise, it would not be a line. Oh, Catherine. So, like, it was wrong. All right. What happens when you guys got something crazy going on? You get an extraneous solution. An extraneous solution is a solution that is not a solution of the original equation. It's something you get, your equation spits out at you, but it's not an actual solution because it doesn't work. So somewhere, you guys can put that in your own words because the book definition, site. So an extraneous solution, it's not a solution of the original equation, but it's something, it's a number, an answer that your equation spits out at you. So let's see how that applies to this equation right here. So if you look, I do have everything solved on the left-hand side for absolute value. So I'm going to write 2 possible outcomes. Pick the one where it's the positive one first. So the one just as it is without the absolute value, and the one taking into consideration the opposite of each one. So you want to make sure if you have more than one term on that right-hand side, parenthesis and put a negative in front of it. All right, I'm going to deal just only with this one right now. So 5x, I have no distribution, no like terms to combine, so I'm going to bump down to step 3 on my solving equations, and I'm going to add or subtract a smaller variable. Which is smaller, 5x or 7x? 5x is smaller, so he goes. Then I'm going to subtract 14 from both sides. Negative 2 minus 14 is negative 16. At this stage, when you are in Algebra 2, you should be able to do these integer values. Negative 2 minus 14 is equal to negative 16. If you can't, please let me know right away so I can give you some integer practice, because that is definitely a skill that you are going to need to have some proficiency on. It's like trying to drive a car when you don't know how to turn on the engine. So it's nearly impossible. Unless you're in neutral, you're just coasting. Still technically drive it, right? But it's not the desired outcome. All right, so my first answer that I got out of my equation is negative 8 equals x. Okay, we're going to let that sit for a moment, and we're going to come to our second equation here. The first thing I'm going to do is distribute out this negative to both items inside my parentheses. Negative 7x minus 14. Now here's where it changes a little bit. Between negative 7x and 5x, the smaller one is negative 7x, so he gets added to both sides. Then I'm going to add 2 to both sides. Negative 14 plus 2 is negative 12. Last step is to divide both sides by 12. And I get x equals negative 1. Since the topic is extraneous solution, my guess is that one of these guys is extraneous. One of them, it doesn't work. So I'm going to give you a moment. Go ahead and pause the video. I'm going to give you a moment to plug in x equals negative 8 and x equals negative 1, and you tell me which one, if any, are extraneous. All right, so let's plug them in and see. We have absolute value of 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. What is 5 times negative 8? Negative 40 minus 2. 7 times negative 8? Negative 56 plus 14. 40 minus 2 is negative 40. Negative 40 minus 2 is negative 42. 56 minus 14, that's negative 42. Is the absolute value of negative 42 equal to 42?
Oh, they both work.
No. There is never there's never a case where the absolute value is going to give you a negative answer.
Sorry, I was thinking that I was like totally on a different train of thought. I wasn't even talking about this problem.
Okay, good. So we know negative 8 is a no for us, so we're just going to say no, and it's okay. Is it okay that we did all this work and this is not a real solution? Yeah, it's fine. It's totally fine. It's totally fine. Welcome to being a parent where you do a bunch of work that is completely ineffective. It's lots.
Yeah, the kid ends up suffering.
So we are going to plug in the negative 1, same place we plugged in negative 8, and see if it works. Sometimes it helps to hear the math out loud, and when you're wondering if you've gotten the right answer or not, go ahead and verbally say it out loud to yourself, just as a check. Sometimes that the voice out loud is helpful to finding the right answer. Okay, negative 5. 5 times negative 1 is negative 5. Minus 2 is negative 7. 7 times negative 1 is negative 7. Negative 7 plus 14 is 7. The absolute value of 7 is 7. Is that equal to 7? So this one checks out, and x equals 1 is our solution. This guy gets to be called extraneous. How do we spell that? A-N, extraneous. Because if we don't spell it right and we try to take a quiz and we try to type extraneous, it will mark it wrong if we don't have the right spelling. So we want to make sure we got that spelling correct. Guess what? In math, spelling math. All right, so that's the equations. Now, absolute value equations. Now we're going to deal with absolute value inequalities. So our essential understanding, which I don't want you to write down, but I want you to have an idea of what essentially we should be understanding in this section. You can write absolute value inequalities as a compound inequality without absolute value symbols. So go ahead and write this part down, solving the absolute value inequality, absolute value A less than B. When we have a scenario with less than, we can rewrite it as a compound inequality. So go ahead and write this inequality here. When you have a less than, we can write the negative version of this 8 and the positive version of this 8, and whatever's in our absolute value goes in the middle. Okay, so once we rewrite our less than absolute value inequality as a compound inequality without the absolute values, we then have not only two sides, but we have three sides that we have to do the exact same thing to. So we're going to add 4 to three sides. So negative 8 plus 4 is negative 4. 3x is left. And 8 plus 4 is 12. Then I'm going to divide all three sides by 3. And by the way, remember when you divide or multiply by a negative, it changes our inequalities. In this case, we have a positive, so no need to worry. So this is negative 4/3 less than or equal to x less than or equal to 4. This is the solution. We have to graph it. So I got a number line. Guess which two numbers are going to go on my number line? I'm going to have closed circles because I have an equal to. And I'm going to shade in between. This is why I love this guy, because the x is in between, which means all my shading happens in between. It's a little like, what's that, guys? Baymax? Or Baymax? All right, so we're going to solve the absolute value inequality for the other scenario where we have a greater than sign. So go ahead and write this on your paper, the absolute value of 5x plus 10 greater than 15. In this scenario, we're going to rewrite as a compound inequality. So we're going to write one version of it, and then for the negative version, we're going to flip it. So in this case, we do the 5x plus 10 greater than 15. And then now when we go 5x plus 10, and we take into account the negative 15, we are going to switch that sign. You still write it like the first way, too? No. Because instead, the first way, everything in between those two values is going to be there. This way, it's going to be the opposite. And everything, all else, except for the stuff in between, it's going to shoot out left and right. So the difference between the one we did before is our sign. This is a greater than, and the one before was a less than. So in the situation where you have a less than, you do it like this. In a situation where you have a greater than, you split it into the two. So we're going to do the same process for both of them. Both of them we're going to subtract 10. And then we're going to divide both sides by 5. So x is going to be greater than 1. Or x is going to be less than negative 5. So the graph of this one looks like a number line. I'm going to put negative 5 here. And 1 here. We have open circles because we don't have an equal to. And we want to have all the values that are greater than 1. So it's everything to the right of this 1. And we want all the values that are less than negative 5, which is all the values to the left of 5. All right, so we're going to talk about tolerance. A manufactured item's actual measurements and its target measurements can differ by a certain amount. called tolerance. Tolerance is 1/2, and we need to highlight this because this is the definition. Pull my highlighter out. And you guys can write that down. Tolerance is 1/2 the difference of the maximum and minimum accepted values. Tolerance is 1/2 the difference of the maximum, minimum accepted values. So you take your max minus your min, divide by 2. So if we look at problem 6, in car racing, a car must meet specific dimensions to enter a race. Official use a template to ensure these specifications are met. What absolute value inequality describes the height of the model of race car shown within the indicated tolerance? So if you look, least allowable height is 51, greatest allowable height is 53. So if I were going to find my tolerance, you go 53 minus 51 divided by 2. That equals 2 over 2 or equals 1. So 1 is our tolerance. Oops. Sorry. So if we're going to write that as an inequality, we take whatever our actual height is minus our desirable height, which is in this case 52, and that has to be in between -1 and 1 of the actual height, because we can be 1 inch below that or 1 inch above that. So we take our tolerance, write the -1 down, write the +1 down, and our height minus our desirable height. And that's answering the question, what absolute value inequality describes the heights of models of the race car shown indicated tolerance? Now if I were to write this as an absolute value, it would be the absolute value of h minus 52 less than or equal to 1. All right, so you guys all have this problem written down. Suppose the least allowable height of the race car in problem 6 was 52, and the desirable height was 52.5. What absolute value inequality describes the height of the model of race car shown within the indicated tolerance? So the first thing we're going to do is we're going to find the tolerance. So the difference between the least allowable height is 52. Our desirable height is 52.5. So what is the difference? This is our desirable height and our least allowable. What's the difference here? So what is going to be our most allowable height? Yeah. So what's the distance between 52 and 52.5? So if I add that 0.5 to my desirable amount, I would get 53. So we want that distance to the left and to the right to be the same. Okay, so if our least allowable is 52, and our at most we can be 53, our tolerance is 53 minus 52 divided by 2. So our tolerance is 0.5. So now we take, we're going to use h for height, so we're going to use the same scenario up here. But instead of our tolerance being 1, it is now 0.5. So we're going to go negative 0.5 less than or equal to h minus, what's our desirable height? It was 52. Now it's 52.5. It's less than or equal to 0.5. Now we're going to convert that into our absolute value inequality. So we got h minus 52.5 is less than or equal to 0.5. All right, so take a moment, reflect on our learning objectives and our example problems and all the topics we went over in absolute value equations and absolute value inequalities, and write your summary for what we have learned in 1-6.